In the last of our MATLAB specific videos, we'll talk about logical branching, that is, if statements, as well as loops. So first of all, let's look at a simple if statement in MATLAB. It has the form, a condition, so if this condition is true, you do the next line or lines. Otherwise, you don't do anything. Now, every if statement and every loop in MATLAB ends with the lowercase end statement. So in this case, if the condition is not true, then nothing happens. Simply go on to the next command following that end statement. So here's one where we've looked at a couple of variables, a, b, and c. And this first one says if b is greater than a, which in this case is true, then c will be equal to 0. So the logical is true, and so c is changed to 0. On the other hand, if we switch that around and say, okay, if b is less than a, well, in this case it's not true, so that command is skipped altogether, and c is unchanged and left as a value of 1. Okay, so that's the simple if statement. Often, though, we have an if-else statement, which will be similar to what we had in Excel. In this case, we do one of two things. We either do one thing if it's true, we do something else if it's false. But once again, the end statement is at the end of the if statement. So again, this is on a pass-fail for grades, and you can see that if the grade is greater than or equal to 60, we return the word pass to the command window. In the second example, though, because that grade is less than 60, so the statement is not true, and so we go to the else part and make that a fail. But often there's even more than two possible outcomes, and so that's where the if-elseif-else statements come in. And so here's one where we looked at this in Excel with nested if statements. So we want to convert a letter grade to an A through an F. And so here's the flowchart of how that's going to work, and we'll show the code that goes along with that. So we start out by reading in a value of x, and then the first statement in the if statement is if x is greater than or equal to 90. Then, of course, if that's true, then the grade becomes A, and we skip all the way down to the end and go on to the next thing. However, if it's not true, it doesn't mean that we know what the next grade is going to be if it's less than 90. Instead, we have the else if part of this and say, okay, else if x is greater than or equal to 80, okay, then the grade is B. But again, if that's not true, go to a second else if condition, and then on to a third else if. So finally, we come to the else statement. So if none of those conditions have been true up until now, then the grade is equal to F. And finally, the end statement, which again says, okay, at this point, you go on to the next lines of the code. So the and or can be used to combine conditions, much like they were in Excel. And so in this case, you can see there's an and condition here that says if both of these things are true, then C is equal to 1. But if either one of those is false, that is, if the and statement is not true, then C will become 0. So again, both of those things have to be true for the statement immediately below the if line to be true. Now, that's the if statements, or logical branching as it's referred to. Loops are really important part of any programming language, because usually you want to repeat some commands, and so loops can be used to do that. In MATLAB, you have what are referred to as for loops and while loops. So a for loop will be executed a specific number of times. A while loop will continue as long as some condition is satisfied. So a good example of that is if you put money into an interest-bearing account. If you ask, how much is this account going to be worth in 10 years? Because you know you're going to do this a specific number of times, then you'd use a for loop. If, on the other hand, you want to say how long, when I put this money in, how long is it going to take for it to reach a specific amount, we don't know how many times it's going to go through the loop before we go, and so we use a while loop for that. So the while loop, we show that like this in condensed form, just says that while this condition is true, you're going to keep making those calculations. So again, borrow $10,000 and want to pay it back, then how many months is it going to take you to pay back the loan? Here's what the flow chart of that would look like. Again, define things up top, and don't worry about the specifics here, but the key is while the balance is greater than 0, you're going to keep doing the calculations. And finally, once that balance is 0 or less, then that part of the loop is terminated, and we go on to the output statements. It's important to remember, though, you could get into what's called an infinite loop there. So if the payments are not enough so that the balance keeps going up instead of down, then theoretically those calculations will continue until you stop it. And to stop it, use Control-C to terminate that execution. Now the for loop, again, is when you know exactly how many times you're going to go through the loop. And so you start out, you have to have a counter with the for. So you can see that first one says for k is 1 to 100. That means you're going to go through 100 times. In the second case, for I is equal to 1, colon 2, colon 7, that means that the first time through, that counter will be 1. The second time through, it'll be 3, then 5, and then 7. So the number in the middle is the increment. And so again, the condensed flow chart looks like this. And we always like to put a connector at the bottom here. And remember that when you do this on a flow chart, it kind of reminds you that in MATLAB there's going to be an end statement always at the end of a loop or an if statement. Alright, so you'll see also that MATLAB with all the loops will indent those statements between the for and the end, which kind of helps you keep track of that. And so if we run this, what's going to happen this first time through the loop, then the value of the counter, j, will be equal to 1. The statement will be that because j is in parentheses, it says x1 is going to be equal to 5. So that tells you right away that we're going to be creating an array as we go through this loop. And as we go through 10 times, we end up with a one-dimensional array with 10 elements, the last of which will be a value of 50. Now, in the last one we talked about using element-wise operations, and so really it kind of has a parallel to what we've just done with loops. And so we can think of the loop as being vectorized, vectorization, where we've created an array without really having to define a loop. Again, just remember you have to use the decimal place before the multiplication, division, and power to be able to do that operations for each element of the array. So if you just look at what we at a possible vectorization example, instead of having to do this in a loop, if I simply define an array of x values from minus 10 to 10, and if I leave the middle number out, as we know that's going to default to 1, so that's going to be just integer values between negative 10 and 10. Y then for each value will do this calculation. So again, we don't have to use a loop to do this, but we've created two one-dimensional arrays that can then be plotted. And so again, this is something that doesn't exist with other computer codes, and because MATLAB again is specifically written to work very well with matrices or arrays. Again, it's a feature of MATLAB. So again, whenever you're using this element by element operations, you can think of that as being vectorization. One last thing to talk about, and that's the break command, and that will cause you to get out of the loop immediately. So we'll say that in this case we've got an example here with the break command inserted in an if statement. So if a is equal to 3, break. So what will happen is, excuse me, as we start going through the loop, Originally a will be 1. We keep adding 1 to it, but the third time through where a is equal to 3, at that case the execution of the loop discontinues at that point. We go to the end out of the loop and just report the value of a back to the screen. So a lot of times that kind of statement can prevent you from having an infinite loop if you have the condition such that if this is encountered, will terminate executions. That's the break command. So a couple of key points here. Loops allow for repetition of the commands. A for loop says you're going to go through a specific number of times. A while loop keeps going as long as some condition is satisfied, but always remember there is a possibility of getting an infinite loop with a while loop. And always remember every loop statement gets concluded with an end statement. Okay, so next time we'll start talking about applications of both MATLAB and Excel.